and I've got voices coming from everywhere. It has to happen in ATV, of course, and we'd miss it if it didn't. Welcome to the I think, what number is it? 233rd net from Mount William. And just as a bit of trivia, it's my 182nd net. So, and I'm standing in for Neil, VK3BCU, who's enjoying a well-deserved rest, and will be back eventually. But I'll hold the fort with others with a bit of luck in the meantime. All right, enough twaddle. Let's move on. Dave Dave from BATC Portsdown fame. And do you think I can remember G8GKQ, his call sign, and he's been restoring a HP or refurbishing a HP spectrum analyzer, and it's a lot of the filtering and stuff has been retained, but a lot of the oscillators and fine electronics of the original were not really recoverable, I believe, and so he's basically put a Portsdown heart in it, and part of the rebuild he had to redesign and resurrect the panel with all the intricacies of knobs and dials and things. So he came across a very interesting package called Panel Designer, and that's what he's going to explain in this next package. Take it away, Dave.
I've been working on the on my spectrum analyzer, which is nearly finished. So let's show you what I've done on that. Just sort this out. There we go. Fade. Yeah. Right, that should come up. That's how it now looks. You'll see it's got a real front panel, not labelled, not stuck on labels, it's actual real labels. I did that in Front Panel Designer and exported it, put it into Photoshop, played with it a little bit, and then printed it onto A4 sheets of sticky paper and put them on the metal, and then put sticky back plastic on top of them. So and that took about a day in total to do that, so I was really impressed. I don't know whether people have used Front Panel Designer. I'll just show you a closer view. Actually, that's how it looks sort of close up. I can show you the Front Panel Designer program, which I was very impressed with, actually. Let's get rid of that, and have a look at... have I shut it? No, I haven't. There we go. That should now come up. That's the panel in Front Panel Designer. You tell it what size you want, and then you can place things on it. Now if I zoom in, for example, there's one of the pots. Well, it's not a pot, it's a rotary switch. And you can customize the arc, the length of these little bits here, put your own text in. If I double click on it, you will see, oh no, wrong place to double click. Try clicking there. That's the hole. It's a 7mm hole. Let's see if I can find it. No. Oh, I know what to do. Let's do that. And you bring up something like this window here for an arc. Just make sure that's in the view. It is. shape of scale, round, radius of the arc, starting angle 30, end angle 120, number of tick marks, length of the tick marks. Do you want labelling on it? I say no, because I want custom labelling. And I managed to export that as a PDF and then put it into Photoshop and print it from exactly how I wanted it from Photoshop. So I was really pleased with that. Let's get rid of that. With the lid off, that top view. Let's move the image just slightly. Oh God, didn't mean to go there. There we go. That's how it looks on top. Power supply, the old HP bits down here, SDR in there, DATV Express in there, and tracking generator there. I can also bring it up. That's what it's doing currently. It's having a look at a signal from the signal generator. So I might even get round to doing something on port stand 5 now once I put the lid on this thing.
So there you have it, front panel designer. So if you need to redesign a panel or something similar, then that might be the go-to piece of software. All right, just before I pass it on, the running order at this stage is, I'll pass it on to Peter on RTV1. Peter, if you could pass it back to Mick, VK3CH. And Mick, if you could pass it to John, VK3ATV, and then John, if you could pass it back to me, and then following up will be Joe with dunking part 2 with a bit of luck. Joe, VK3TET, and then followed by Stephen on RTV1. So we'll work out the changeover there from Joe to Stephen, but we'll get there. That's the sort of running order as I see it at this point in time, subject to change and all of those little liabilities and contingencies. Right, so where do I go now? Oh, I'll just, just a heads up, after this segment I'll pass it to you, Peter. Here is the promo for the field day coming up late this month.
Get your gear ready and mark your calendars for the Winter VHF and Microwave Field Day. This is your chance to test your skills and see how far you can work on VHF, UHF, and microwave bands. And the best part? There are plenty of sections for single and multiple operator stations, including a separate home station section. But that's not all. Field days have a high level of SSB activity, so you'll have plenty of opportunities to make those FM and SSB contacts. For all the details, be sure to check out the WIA contest webpage.
Right, well I see Peter is there on RTV1, so if you'd like to switch to RTV1, and Peter, after your segment, if no one else on RTV1 comes up, then we'll, if you could pass it back to Mick, VK3CH, that'd be great. And then Mick, you pass it to John, VK3ATV, and John, pass it back to me. That's the running order as I said. All right, Peter, we'll RTV1, people switch over there now.
we should be talking. Got to press the right buttons over there. My ATM unfortunately is over there, but I do have a control over here as well. Anyway, good evening. I'm Peter, VK3BFG, and g'day to Fred, 3ZAQ, who's always generally watching. I know Fred. He's a member of the Eastern Mountain District Radio Club, as I am. And it's the annual general meeting, I think, on Friday night. So we all better get there and duck so you don't get a job. I think I've done my little bit there, but anyway, I hope the current president keeps going. He's very good, but time will tell on that one. Of course, you know, it's a fairly big job, and he's done it for 2 or 3 years now, if not a little bit longer. Anyway, we'll see what happens on Friday night. Well, the repeat has been going pretty well, and I shouldn't be saying that. So I haven't actually been up again this week, so that's some kind of a world record. So let's hope that it keeps going that way. And to John, 3ATV, I'm doing an Angel flight on Thursday, but unfortunately I'm totally weight restricted. So yeah, the gentleman and the lady, particularly the gentleman, is very big. And I'm taking somebody down to Malakuta, and anyone can watch on Flight Radar, by the way. That's a little app you can put on your phone or on your PC, and you can follow any aircraft of any tail number. And my tail number is Delta Kilo Charlie. So if you just go into the menu and pick up Delta Kilo Charlie, you'll be able to follow me. But I've got to pick up at Essendon, and then that's just one person back to Malakuta. But then at Malakuta we've got a very big gentleman and his wife, and 20 k's of luggage as well. So yeah, we're right on the limit there for takeoff. So not having to go up to the repeater, I've had the opportunity to do a little dabbling, and I do support silicon chip. It's not often that there's something in there that interests me in terms of a kit, but this month they put out a battery checker, and it looks as though it's going to be very good. It's certainly advertised as being able to test pretty much any battery, including lipos, where you've got fairly high currents. And it's got a little microprocessor in it, of course, and the processor reads the voltage across a 15 milliohm resistor. Where they ever got a 15 milliohm resistor from, I have no idea, but it's probably in the instrumentation somewhere, but that's what it does. And it's a sequence of pulses, and it stresses the battery up until it decides the battery's not coping anymore, and then it'll stop. So I've got to the point where I've just about switched it on, so I'll show you what it is this week. And I haven't gone through the calibrate procedure or anything like that, so next week we might have a fairly hefty lipo or something like that there, and we'll see what happens. But we'll just turn the camera over to here, and you can see the device there. And we'll just stand it up. It's about to test. Oh, I think we're seeing it. Yes, we are. Excellent. It's about to test the AA cell here. So we'll just drop that back there, and I'll press the start button, which is up there, not up there. And fortunately, to my delight, it actually has come up. I know you can't see that because the camera probably wouldn't be able to reproduce that anyway. But it's saying I'm running off a 9-volt battery, which I am inside the device, and it's identified it's a 1.5 volt battery, and it's going to go up to a maximum current of 1 amp out of that, would you believe, for a very short time. But I haven't done the calibrate, so it's not going to go any further at this stage. But next week we might be able to show you a little more detail, and I'll work out how I can get you to see the display there. So that's what filled my day, basically. The kit wasn't all that expensive, considering what it potentially will do, and I've got a number of LiPo batteries that I use for my model aircraft, so that device will be very good for that. So I think I'm sending it over to Mick, VK3CH, so Mick, you could start rolling on RTV2 with DVB-T, and I'll just wait until I see Mick come up on 2, and we'll drop off, and hopefully we'll be able to show you the battery tester in action next week. I think Mick is coming up. Yep, he's there. So over to you, Mick. This is VK3BFG.
All right, says we're there, and that should be audio. Yep, all good. Yeah, all right. Don't really have a heck of a lot to say. Oh, we're Mick, VK3CH, Doncaster. Good evening, all. Haven't been doing a lot on electronics. Been shopping for bits and pieces for another thing that we want to build up. So just worked out some cables and stuff that we need. So let's see, some of the main things we want, there's a big lead time on them, nearly a month. So and then when they all turn up, then we've actually got to build it, and it involves cutting some pipe, which I'm not going to do with a hacksaw. And the workshop that I take that around to get done, they're not reopening till August, I think, so a bit of delays. So anyway, and I just got a email that's arrived for some locksmiths that I dealt with, not me, but on behalf of someone else. And it's got overpayment, balance due, and there's a comment in the balance, but then there's brackets around the number that's due. And in accounting, brackets means a negative number. So the way that reads to me is I owe them minus 147, which means they owe me 147. So that only just dropped in the email minutes ago, so I'll ring them up tomorrow and work out what's going on with that. First one I've got an email like that. What else have we done? Not really a lot. Yeah, coming in on RF, which we seem to be doing for the last few months. That's with no house next door. But I don't think they were really that fault. There's just an edge of a little bungalow that's partly in my way to the repeater. It doesn't really block it. It blocks part of it, maybe 30% or something, but maybe that's enough to annoy it. I don't know. It sort of worked pretty good. I forgot when it was raining today to put a carrier up to see how it would go in harsh rain, but I'll have to remember to do that. Oh, that's about all I've really got for you. Not much else I can talk about on an electronic vein. So I'll hand it over to John, VK3 ATV. Over in Williamstown, we're coming in on T. So that should make for an easier cutover for you, I think. I think you're using T. So we'll catch you next week, hopefully. Cheers from Mick.
Good evening, everyone. Good evening, everyone. Make sure I've got audio. John, VK3 ATV. Got a fairly short one myself tonight. I'm currently using the Portsdown 4 with the Pluto. Seems to be working okay, but I'm only using the PiCam. That's the only video that, apart from the internal test pattern, that I've been able to get to work. So I am looking for ideas from anybody who's used the Portsdown 4 with the Pluto as to how to get a video into the unit. And I don't want to use, I'm trying not to use a computer. I want to have this as a standalone system. So I just want to be able to put HDMI directly into the Raspberry Pi. So I did manage to get the PiCam working with the audio. You have to make sure that you've got an audio USB audio adapter plugged in as well. So that's working quite well. But in terms of getting other video into the system, tried a micro HDMI to HDMI cable into the Raspberry Pi. That didn't work. I've tried a USB to HDMI adapter, and that's a fairly good one. I've used that on a few things. That didn't work. And Neil lent me his fairly expensive CamLink USB to HDMI, and I couldn't get that to work either. So I'm scratching around a bit, trying to find out how I can get HDMI into the Raspberry Pi and get the Pluto to transmit it. I've followed all the suggestions on the Portsdown 4 website pages, and still haven't had any success. So if anyone's got any ideas, please email them through, or I'll try and catch me on air, which doesn't happen too often at the moment. But anyway, that was just wanted to show that the Portsdown 4 does work, but the PiCam obviously doesn't give very good resolution video. The other thing I wanted to talk about was the upcoming Melbourne ATV group meet and greet, or face-to-face meeting. I've put out an email to everyone I know on the Melbourne ATV group list for 3 potential dates. That's the 12th, the 19th, or the 26th of July at the ARV club rooms. So I've had a few responses. All seem to be available for all dates. So I'm tending to go towards the later date to give us a little bit more time, unless somebody comes back during this week and suggests that one of those dates isn't suitable for them. Otherwise, it'll be possibly at this stage 26th of July, unless I get some more comments back. I've already got 2 people that have agreed to do a presentation. I'm only looking at a 5 or 10 minute, well, probably 5-minute presentation. So Stephen TTF has volunteered, and also Mick 3CH has also said he'll do a presentation on his car installation, which most of us have seen a few times on through the repeater, but probably not too many of us have seen in the flesh. So that'll be interesting. So please, if anybody else has got something to show, you don't have to get up and stand in front of a podium. It's just a room of people
that would be interested in what you're showing. So if you've got a project that you've been working on that's ATV or related, please let me know. If you didn't receive the email, ask one of the ATVers or send me an email, and I'll send you the details. That's about it from me. Next week I'll probably be back onto the high-def DVB-T transmitter, much better quality. I've been fairly busy over the last month or so planning, and Richard would know what this is like, but I'm planning a fairly large event. I have been involved in the event for many years, but this was the first year I was the chairman of the committee and event manager. So and it's a historic racing event in near Benalla, or at Winton Motor Raceway, called Historic Winton. So that you'll be able to see a few parts of that on Facebook. If you just or if you just Google Houston, there's a page, web page on that. All right. So that's what's kept me away from ATV. So hopefully get back to that again and get a few of these projects done. That's it from me. I think it is. You'll have to let me know, Ian, who it's going to next.
Back to me, QL.
Okay. All right. So it's back to Ian, VK3QL, and he'll be on RTV1. So stay tuned on this channel. Thanks everyone for watching, and we'll hopefully see you again soon. This is John, VK3ATV.
Right, thanks, John. And no, that's that Portsdown. Yeah, the Portsdown with the Pluto, I think it was. Seems to be going well. But I hope you can solve the problem with getting video into it without a PC. I think it's without a PC is the issue, but I don't know if there's a solution for that. All right, and Mick, thanks for coming up, and Peter, the kit, actually I have not built a silicon chip kit for a very long time, so it's great to see they're still putting them out. They're a great way of learning how lots about electronics. I should have learnt more. But anyway, we won't go there. All right, after me will be Joe, TET, with a 12-minute presentation, and then over to RTV1, Stephen. But Joe, if you'd like to pass it back to me, I can then hand over to Stephen and for a similar length of segment. But before we do, why not have a quiz? black screen for a while. Right, I just want to acknowledge Fred, as was already been mentioned, is a keen watcher. VK3ZAQ, and also Greg, VK3QSL, is watching, and Vince, VK3YVS. We also have on YouTube is David, VK2DJV, and John. Oh, John just come up. ATV. So that's good. Hello, John. Again. Right. What's next? Cab off the rank. Oh, and Mark, VK3PI, is watcher. Bob, also VK3BVR. I never, always disorganised with acknowledging watchers and the like when I run this net, but anyway, practice makes a bit better. I was going to show some footage of the aurora, but there's a lot of activity from the sun at the moment, and there's a lot of sightings of aurora down south, so something to keep an eye open for. And yeah, so I just sort of mentioned that. I'd actually lined up the footage, but I haven't put it in the system, so I'll have to hold that. What was I going to say? Just whizzing through things. The event calendar, as mentioned, was is right down the bottom. Is Saturday, looks like it's going to be the 26th of July, 10 till 2, I think is the notional time for the meet and greet at AR Vic. Ashburton, AR Vic, of course, a great supporter of our repeater and our activities. So if you can see your way clear being a member of AR Vic, that'd be great. Also, in the next weekend is, then it's the log weekend, the 7th and 8th, the Australian Fox Hunting Championship, Mount Gambier. I have never been able to make that, but I believe it's a great function and it's on the bucket list. 21st and 22nd of June is the Winter VHF-UHF Microwave Field Day, as mentioned. A big shout out to those who were able to bring up to date all the contest logs for that field day in the past. They were they sort of fell into a bit of a hole due to various reasons, and it's great that there's been a catch up on all that. The July the 5th Saturday is the Ham Fest for the Greater Gippsland Radio and Electronics Club, and it's at Langwarrin, which I don't know if they've used that before, but I certainly haven't been to that venue, and so it's about a 60-minute drive from Dandenong due east, so, or approximately due east. So that's on. So that's the story there. And for those who like more difficult quiz questions, here we go. 1, 2, 3. Yes, I've got a problem with a battery, or actually it automatically shuts down the wireless mic. I was saying some very important things and I've just forgotten what they were. So yes, so Joe, VK3TET, will be coming up next, and then Joe, if you pass it back to me, I will pass it on to Stephen, VK3TTF. All right, Joe, I'll drop carrier, and if you'd like to come up, catch you soon. Says he, thinking.
Okay, thanks for coming back for the part 2. There's a couple of things. There's quite a lot of things actually. So I decided to include a couple of extra little experiments just to show that when you have cold water, everything does not come into play. In other words, basically hot water is the catalyst for all of the interactions and chemistry that goes on. If we don't have hot water, then things don't work, and this is just a few experiments just to prove that. So the first experiment was just to get some hot water and do the test. One of the things that we didn't do last week was to check to see, do we really need tea? Or is tea just a masking agent? In other words, hot water is the main catalyst, not so much whether it's tea or not. So this is just a simple test to demonstrate the fact that tea is irrelevant. And when we dunk a biscuit into hot water, it takes about 40 seconds or so to break up. If we dunk a biscuit with hot water with milk, it takes about 16 seconds for it to break up. Very similar results to last week with the tea. So that's basically the first part. The second part that I try to demonstrate is what happens when we have such solutes into solution, in other words particles. And one easy way of doing that is to put salt into the solution. If we saturate the water with salt, technically it should improve the osmosis process, which does influence the breakdown of the biscuit. However, once again, it's not very effective if it's not hot water. And in cold water, with the salt particles and the solutes in the solution, like milk, it has virtually no effect. In other words, high concentration with salt or milk or just plain water has the same results, which is interesting. That just proves the fact that hot water is the catalyst. Anything, just plain water, okay? So let's just start the timer at the same time that we dunk the biscuit, okay? So here we go, ready, steady, go. So it should take about 20 seconds last time we did that with the tea. So the biscuit's still pretty solid. Okay, that's 11 seconds, still solid. 20 seconds, still solid-ish. Yeah, it's about getting there. All right. No, it's still solid. Well, that's gonna be about 40 seconds or so, give or take something, because I've been pulling it out of the cup. So let's say 40 seconds for the dunk. It's getting all very puffed up, but it hasn't broken down. That's about it. Okay, so about 40 seconds. All right. Now we've still got the water here. Let's put 1 drop of detergent inside. Here we go. We should get some bubbles. Okay, we are getting some bubbles. Okay, now we can see the soapy bubbles on the top of the glass. Okay, so let's now try it. It should be very good, well, the surface tension should be broken now. Ready, steady, go. Well, 12 seconds. It's getting all puffed up. 18 seconds, yep. Okay, we can see the biscuit breaking down. It's probably broken down at about 18 seconds, but give or take a couple of seconds that I've been lifting it out of the water, let's say 16 seconds, okay? So very, very similar to the result with the milk, which is what we expect, because the milk is actually breaking the surface tension. And so is the detergent in this case. Much more than before. Yep, broke down. 25 seconds. 26 seconds. So, surface tension definitely has an effect. Surface tension definitely has an effect. So we've proven that. Now there's one more test, and this is the real test. One of the things that may not be that obvious is that the reason that the biscuit breaks down is to do with osmosis. Let's have a look at the slide about the osmosis once again. Osmosis really requires some solutes, and milk is a good solute, right? So the fact that milk works very well, it has a double effect. It is a surface tension breaker and also a solute. And when you have osmosis, to test the osmosis, we're going to put particles in the water, okay, particulars. So basically the easiest way to do that is just to add salt. Okay, in short, what this should do, this should accelerate the osmosis. If it is osmosis, right, by putting salt in there, we are proving that the biscuit is breaking up because of the osmosis. Okay, because if it goes really quick now, biscuit breaks up quickly, it means that it is osmosis. Meaning that the milk creates that or accelerates that. So here we go. Let's start the stopwatch again. Go. 1, 2, 3, 4, 5, 7. It's getting 13 and 19. Yeah. Still harder. No, doesn't look like it's having a big effect. It's like before. Yeah, it's going to break down about now. So we're talking about roughly the same time as just plain water. So salt didn't have a big effect, which means osmosis is not necessarily the reason behind it. Okay? That's the test. Now, let's go for the science, all right? Although osmosis is a contender, it is not the most significant. It has negligible effect in our experiments. So we can conclude that it is not such a strong influencer of the biscuit breaking down. And let's start the dunk. Let's put it down here. Ready, steady, go. Okay, what I'm doing here is doing 3 experiments. I'm going to be using salt water, I'm going to be using detergent, and I'm going to be using milk, all in cold water, just to see if it makes any difference. And obviously it does make a big difference. All biscuits, basically roughly 3 minutes they can last, and I just stopped it at that time. The reason is that it just proves the point that hot water is an accelerant. If there's no hot water, the biscuit is not going to break up any time soon. The next test, we'll do the same thing, but without the salt. So let's just get a new cup of water. So let's reset the clock. And ready, steady, go. Okay, we're reaching 3 minutes and it still hasn't broken down, so let's assume that the salt water has a negligible effect because we're roughly the same. So I'm going to stop it here and conclude that the salt water had a negligible effect in cold water, or room temperature water I should say. Okay. Right. Let's just do one more little test whilst we're here. Roughly a tablespoon of milk in there. Oops, a little bit more. Let's say that. And we're going to stir that just to mix the milk in there. And put the biscuit in there as well. Ready, steady, go. So we're over 3 minutes, it's still holding. So let's conclude that. Let's look at the science behind the biscuit breakdown. The key factors are heat, osmosis, and surface tension. We did a couple of extra experiments just to isolate a couple of things and prove some other aspects. First of all, we've proven that tea has virtually no effect. The same results are obtained with hot water, just plain hot water and milk. Now, heat is the key catalyst here. If we use cold water, we don't get a result. Essentially, the biscuit can stay in cold water for over 3 minutes, whether there's milk in it or anything else, it makes absolutely no difference. Now, obviously heat is a key catalyst here, and it is very, very important for this to sort of take place. The interesting thing is that osmosis comes into play, and milk contains both activants. In other words, it breaks down the surface tension, and it also has particles or solutes which helps with osmosis. So it's the ideal additive to the water to create an effect where the biscuit breaks down very quickly, which we have proven. So before we finish, let's have a closer look at the science of surface tension. A little short animation here with some more details of the explanation. Particles that make up a liquid are in constant random motion. They are randomly arranged. You might expect that the particles at the surface, at the micro level, to form a random surface also. But how do intermolecular attraction influence the surface? Under the surface, intermolecular attractions pull on the individual molecules. At the surface, pull on the molecules is lateral and downwards. There is negligible intermolecular attractions. The result of this is a downward force that surface particles are pulled down until they're counterbalanced by the compression resistance of the liquid. Surface molecules are compressed more tightly together at the surface, forming a sort of skin on the surface, with less distance between them compared to the molecules below. Surface molecules also form much smoother surface than one would expect from randomly moving molecules. A small water droplet forms a spherical shape because of the net direction of all the forces pulling towards the center. When dropping through the air, the molecules are still being pulled towards the center. This is why, when a drop forms, it forms a spherical shape. A perfect example of that is a zero gravity, when you see a drop which turns into a perfect sphere. I hope that sort of gives you some idea of what surface tension is.
One, two, three, yes. Actually, I know what would fix that, hopefully. All right, thanks Joe for that, and yeah, it's a very interesting, detailed. So they're great. It's sort of 2 episodes, so and good coverage. Just a bit of feedback, Joe. There's some post-ed audio going over your first clip, and there's at least about big difference in the different level of audio. So I don't know if it's possible to increase the level of the dubbing audio that you put in after the first lay down of video and audio. That would help people with set-top boxes trying to juggle audio. So that'd be good if you look at that, and happy to provide any feedback if you want to run some tests. All right, now we have Stephen, VK3 TTF, a new starter on ATV repeater, and with some very interesting stuff to date. So, and he's currently on RTV1, and so people might like to switch across to RTV1, and we'll let
All right. Hello, everyone. Yeah, it's been 3 months since my first transmission now. This is my third net. Didn't get on last week's, just didn't get quite ready enough for that one. So yeah, third net in, 3 months. It's all threes tonight. I may even have 3 pieces of things I want to go through, so that would be good. Yeah, for Peter, 3BFG, I've actually been feeding into Float Radar 24 for 13 years now. So yeah, I'm a Rubbin 1. I was the very first person in the southeast of Melbourne to actually feed into that. So that's pretty cool. Been doing that for as long as I've been doing some of my satellite work as well. So tonight, a bit of agenda, a bit of an update on the controller board from a couple of weeks ago. I just want to pick one component, sorry. The VCO, the oscillator, just talk about that and the libraries I use for that one. And go through doing a bit of a live demo with the Raspberry Pi Pico on that one. I'm breaking all the rules of TV. Don't work with kids, don't work with animals, don't do live demos. Hopefully it goes all right. And if we've got time, I might do one thing, but I think I probably might leave that to the next net as well. So really, controller update. So I haven't really worked on that specifically in the last couple of weeks, but I do want to thank VK3IE for forwarding it on to the BATC guys. And I know Martin, G8KOE, is watching tonight, hopefully. I can see him on the YouTube. So all good. Thank you for sharing that one. Hopefully lots of more updates and things like that coming in the future. On that one, I'm just going to turn my lights down. I think that's a bit too washed out on my face. Yeah, so hopefully some more updates on that one coming soon. So tonight though, I want to go through some Raspberry Pi Pico. These are not Raspberry Pis, these are Raspberry Pi Pico. It's a very different platform. And I'm going to take you through and hopefully actually get one out of its package and set it up all working live tonight. So we'll see how that goes. But the focus of that one, why I want to do that one, is around the little VCO modules. So you guys might have seen these modules. I think quite a few people actually use these ones. This little module you can get off your favorite Chinese website. It's got the little oscillator in its screen and some buttons so you can configure it all up. What I'm using for the actual ATV controller is it's got the same RF chip on it, but this one here. So instead of having the screen and everything like that, we've got a little pin header to actually plug into something else to control it. So based on that one, yeah, obviously you can't do much with the board as it is. On people that would have seen the original post, this is actually upside down on my controller board, so it plugs directly into the board and is actually controlled. So what I want to do now is change over hopefully to this. Does that work? Yes, that looks good. So these are the Raspberry Pi Picos. So these are a little, sort of like a bit like an Arduino. I'm sure everyone's heard of that. A little bit more powerful. Arduinos are usually sort of 10 to 16, maybe 20 megahertz. These are actually dual core 133 megahertz. And these ones have got Wi-Fi on them and things as well. This one I'm holding is actually only about $6 to buy. The most expensive, the version 2 with the Wi-Fi, is about $12 Australian. So these are really, really cheap to play with. And I'm actually using one of just these cheap $6 ones in my ATV controller, running the web interface and everything on that. So they do a really good job. So what I want to do is just take you through these, and then I'll do a quick demo of just getting one working to show you out of the packet how quickly it actually is to actually set and use one of these up. There's no compilers or anything like that. They actually natively just run Python code, really easy to implement. So these two on the left here, these are version 1s, with and without Wi-Fi. So with the little can, it's got the Wi-Fi built in as well. Pico 2, so these are just a bit faster. They've also got a separate ARM core that people are sort of just working out what to do as well. I think they're 150 megahertz by default, if I remember correctly, with and without Wi-Fi as well. So, but yeah, if you don't need Wi-Fi in my controller, for example, I'm doing Ethernet. I wanted to keep 2.4 gig out of my controller. Literally, these ones without Wi-Fi are really, really good. So what I'm going to do is, yeah, let's actually get one of these out of the packet. So I'm going to grab this Wi-Fi one, and yes, you can see it's still got the plastic on it. Let's pull that off. Open it up. Hopefully I can hold it up and you can get a really close look at that one. Let's turn that up the right way so everything doesn't look really horrible. But yeah, that's it. So that little chip in the middle, that's the actual microcontroller. If I've got a little pointer here, this chip here is actually the storage. That's the flash storage it uses to store the programs and everything like that that actually run off it. So one button, boot select, and there's other debugs and things like that as well, but you've got lots and lots of I/O compared to an Arduino like the 328s and stuff. You might have 10, 15 pins. You've got about 25 pins of I/O on this one, so it makes it really easy to integrate with lots of stuff. So all I'm going to do is actually let's plug it in. So the first time you plug one of these in, you'll actually hold down the boot select button. It's just one of those little micro switch buttons. You'll probably hear me pushing it there. Hold that down whilst you plug it into the computer. Just uses a micro USB cable. Let that go, and that sits there. Hopefully that's work. I didn't hear my computer go bing because I've got it on mute. And actually I want to put that there for reasons that will be obvious shortly. Hopefully that focuses. Cool. Now I'll flick you back over to the computer, which is that screen there. So this is Thonny. This is a little bit of software you use to program them. There's a few other ways you can use as well. This is just super duper simple. When you plug one in, if I click stop, it's because it's brand new, it doesn't have an interpreter on it. What we've got to do here is go up to options, interpreter. It just comes up when we click that boot select button, it just comes up as a drive letter. It's an RP2. I've chosen the Wi-Fi version 1, so I want that one there, not the 2W, just the 1W for wireless. And usually I just grab the most recent version. So what this is doing is actually downloading like a Python command interpreter onto the actual chip itself. And when you actually upload, it actually effectively compiles and runs in real time. There's nothing you need to do on your computer. All the code that you write is actually stored in normal human readable text on this device, and if you plug it into another computer, take it over to a friend's place or whatever like that, they can put it in their computer and actually see your original effectively source code, because that's actually what runs on the device. So it makes it super duper simple. And there we go. I was worried it wasn't going to work there, but it is done. We can close that, and if we just click stop, we should get, hopefully, I might have to just do an unplug and plug. I did test this on another one earlier and it did work, so hopefully we don't get demo gods tonight. There we go, cool. So down in this corner I've now got a Raspberry Pi Pico. That's the hard work done. What I've got here is a little Blinky app. So this is just Python, MicroPython to be specific. We're just importing a couple of modules. So machine just lets you control the I/O ports. Time lets us do a sleep. We're setting up the LED because we just want to flash it. And what I'm actually going to do is, hopefully this works, if I click that button there, you can actually see what's on my desk as well at the same time. There will be a bit of a delay from the camera to what you're seeing. If the ons and offs don't align, that's why. But if I just click play now, you can see the little light flashing. So that's as easy as it is to get these little $6 boards up and running. So Thonny's free. You can just chuck it on your computer. You don't need to get libraries or anything. These are all just built in, and you've got yourself a flashing light. That easy. What we're going to do now though is build on it. So what I actually use on my controller board is the ADF 4351s, as I showed you pictures of. So the one I do use, let me just literally chuck it. So it's that one there, you can see there that you saw in the picture before. Is it going to focus? There we go. So yeah, with the header. It's not plugged in obviously right now. The module actually just ignores it if it's not plugged in. I'll catch you up with that later. But to actually make one of these little VCOs work, I've actually written a library. All you need to do, so we've got a blank Raspberry Pi here. I've got this library for the ADF 4351. We just upload it to /, which is the root directory of the Raspberry Pi Pico, and you can see it's just files that it actually uploads to this board. We can grab our test file, and I've got a frequency just set in here. 433 is just obviously a very classic free frequency. If I click play on that now, We've actually, if the oscillator was plugged in, it would now be enabled and outputting a 433.5 megahertz sine wave. It's that simple. So using these libraries, you don't have to worry about all your compiling and mucking around with things anymore. Super duper simple. All I've got here is a 10-second sleep, and then it's disabled it, and we can see there that it's actually dropped back to the prompt, so the program's finished running. So it is that simple to control these boards. These boards that I'm actually using here that don't have the microprocessor built in are actually about $20 cheaper than the ones with little screen and the buttons on them. So you can actually buy 3 Raspberry Pi Picos as well as one of these boards for the same price as one of the others. And then obviously using these Picos, in here obviously I've just got a program where I've set the frequency. If people are interested, I'm happy to actually expand on this next week, and we chuck a switch in, and you could actually have a switch inputting to choose, say, 2 different frequencies, let's say RTV1, RTV2 or something like that. Lets you easily flick frequencies. And it's whatever you want to do. You have 2 frequencies, 4 frequencies, whatever. You can program it to whatever you want. All you do is you set the frequency to the correct number that you want, and it will program the VCO to output that one. So because those VCOs, obviously you've got to reach in, open up your transmitter and change the frequency if you needed to. This could literally just be a toggle switch on the front of your transmitter box. So much simpler. So yeah, they're very interesting little boards, very easy to play with. If you guys actually are interested, I actually have chucked up on Discord, sorry, not Discord, GitHub. This is the library page up on GitHub. The link is in our Amateur TV Australia Discord page as well if you want to get to that. Otherwise, just search on GitHub for this one. All the information around the pinouts, where to connect it up to the Raspberry Pi Pico. Chucked it all up there for everyone to have a look at, as well as some sample code and everything as well. So that just makes it super easy for anyone to actually go and give this a try. And this is just one thing you can do with these little boards. So I'm obviously writing quite a lot of other modules and things for the controller as well to control other bits and pieces too. So hopefully that will interest quite a few people. So yeah, that's probably mostly it, I think, for tonight. If people are interested in a few other Pico little projects, hit me up. I'm happy to do a few other little sessions, as well as obviously our ATV meetup late July. If people are interested in that, I'm happy to, people want to put it up, I could purchase a heap of them and bring them in. If people want to bring laptops or whatever like that, we could actually program a few up if people want to give that a try, just because they're so handy. And even people have the little relays on their controllers as well. You could do Wi-Fi on these with, I think, about half a dozen lines of code, and you can have something on the Wi-Fi that you can then control with. So it could do everything, very similar to what the controller is, just a baby version of what I'm working on. So really useful little boxes. So I think just because it's after 9, my next segment I'll actually leave to probably next week. Yeah, I think people are probably ready for bed by now. So after that, I think, Ian, if you want to take it back, I will change over. Yeah, thank you. All good. Thank you all.
Yes. All right, trying to get very smart switching. Thanks for that, Stephen, and yeah, very interesting. And it's great to have Martin on board too. I just had a chat with him offline via All-Star, so that was good. All right, that's all for this evening. Just for those who've been watching the developments on ISS with regard to ham TV, the end of I can't remember whether it's end of June or July, is the plan to configure it for operation. Obviously there'll be testing after that, but so there is movement at the station, as it were, on regarding activating the ham TV on the ISS. So more about that next week. All right, I will finish on my outro, and I'm saying good night from me, VK3 Quebec Lima, and here's good night from Lucy.